Hello everyone, I'm Lee. In this video, we are going to look into object and class and the usage of array. I'm sure everyone here is familiar with all these concepts. So we're going to focus on the Java language aspect, and we're going to focus on the difference between C++ language and the Java language. First, let's open the project. So I'm using BlueJ now, and click on project, open project. I have two ways to open the BlueJ project. This is one way. You say open project, it's in my sample code folder, and object and array, that's one I'm going to open. And the second way to open the project is, last time when I saved the project, I also exported as a jar file, so I can open it through a jar file. So this is how you do it. You say project, open project, but not open project, open non-BlueJ project. So then it will show the jar file. This is a jar file. You can click on this jar file and open it. So I'm going to go ahead and open project using the first way, and object and array, that's a sample project I'm going to use. In this sample project, I have two classes. One class is to define student data type. So I'm using a class to define the new type called student. And another class is used to test this class, and actually I'm going to show you the usage about how to create objects in Java and how to use the object in this testing class. So let's first open the student class. Double click. This is a student class, and again, pay attention to the documentation here. The documentation style, it's called Java doc documentation. And in this file, I have one single class, and that class I call it public, that's access modifier, public class student. This file name has to be the same as the public class name. So it has to be student, start with the uppercase S .java. That's a file name that contains this class. Okay, the first thing you might notice is, in Java, when we create a class, we don't have the .h, the header file, and the CPP file. We don't separate the specification from the implementation. There's just one file for student class. It's called student.java. We have the specification and implementation all in this same file. So you see public class student, and the end of curly brace. There's no semicolon here like in the header file of C++ language, so it's just one class definition. And to make this sample project simple, I only want to model two attributes of student object, that's ID and GPA. To model ID, I use a string data type. You see, string start with the uppercase S, that means it's a class name. This class is included in the Java API. API stands for Application Programming Interface, so it's kind of just like a huge library of Java. We will focus on API in the future weeks. So there's a library class called a string, and GPA, I'm using a primitive data type or a built-in type in Java, and you see it's used to start with a lowercase d here because it's a built-in data type. And also the access modifier, both of them are private, so that's the same meaning as in C++, which means private to this class. So within this class you have access to those two attributes. Alright, so we have two instance variables here. The reason they're called instance variable is when I create an instance of student class, or you call an object of student class, they have their own copy of ID and GPA. Which means if I create two student objects, then they maintain their separate ID and their separate GPA, which really makes sense. Okay, so now let's take a look at those two. Those two. So first of all, the access modifier, this one we got a public one. I don't want to make it a big secret. Take a look at its max credit. That means I want to limit each student, like the maximum credit they can take each term will be 100 each year. Will be 100 here, so it's just an arbitrary number. And since it's a named constant, it's read only, so I want to make it public, not big secret. And that's public. And final means constant in C++. That means it's read only. And static, that's the one we're going to focus on. Okay, so static is called static variable or called a class variable. A class variable means it's at the class level, not instance level. That means for all the instances or all the objects of student class, they share one copy of max credit. Okay, now think about it. This limitation I post here applies to every student. So for every student, this is the same max credit limit, that's 100. So does it make sense for every student object to carry this max credit? Maybe not. So when I make it static, that means for this whole class, there's only one copy of this max credit. So that's static variable or called class variable. And I have another static variable called the number of students created. So I want to keep track of how many students objects were created. So this is not suitable for instance variable, because for instance variable it only knows about that specific instance, but number of students created need to keep track of how many students objects were created. So I use a static variable for this one, and I make it private. I don't want to make it public for public usage here. And it's static because there's only one copy of this variable and it's an integer. And I initialize this one as 0. It's not final because I'm going to change it, but this one is final. Alright, so now let's summarize the difference between instance variables and the class variable, or called static variable. Instance variables means an individual instance maintains their own copy. A class variable or static variable means the whole class share one single copy. So you can imagine max credit and number of students created, they don't live inside of individual instance, but ID and the GPA do. So now imagine if I create 1,000 student objects, I won't have 1,000 copy of ID and 1,000 copy of GPA, because every instance got their own ID and GPA, but I only have one copy of max credit and number of students created. Okay, so now we see we have instance variable and classic variable and class variable, or called static variable. So similarly, we have instance methods and class method or static method. Okay, so usually instance methods are used to manipulate instance variable, and the class method or static method are used to manipulate static variables. So in our example, we have get number of students. That one provides access to num-students created. So it's a static method. And we have get ID, get GPA, and set GPA. Those are called instance method. You see, you don't see static there. Those are called instance method because they manipulate instance variables. So now let's take a detailed look. So the first one, get number of students, pretty straightforward. We just return the static variable there. And then we have two constructors. Constructors are used to initialize instance variables because constructor get invoked when the instance get created. So it makes sense to initialize your instance variable there. It's the same as C++ language. It's the same concept. Alright, so here we initialize ID and the GPA in the default constructor, and we remember to update the number of students created, because now some students got created. We need to increment this static variable. And similarly, in this constructor, we initialize the ID and the GPA with the passed-in arguments, and we update the class variable here. And the only thing I want to raise your attention here is the usage of this. And we're familiar about this in C++. That means it's a pointer to the current object. And here, let's read it this way. It is a current object. But actually, behind the scene, this in Java is a pointer to the current object. But in Java, every object is a pointer. So we don't say that anymore. We don't say pointer at all, because every object essentially is just a pointer. So in C++, the syntax will look this, then the big arrow, and here is a big arrow, but here we use dot because we don't say pointer, we say this is just current object. So that's some syntax difference between the two languages. This dot ID means my ID, the ID for the current instance, and this ID means the passed in temporary variable there. Okay, get ID and get GPA, they're very straightforward, and set GPA straightforward as well to manipulate the GPA. Alright, you see, I didn't provide a method called set ID. That means nobody can ever change the ID after it's created. It's just our specification here. We don't provide a way to change ID. So another thing I want to raise you guys' attention is about the documentation. I'm going to only say it once here, and in the future video I'm not going to talk about it again. So for every method, you need to document the method using Java style documentation /2 star and end with */. And the first sentence should summarize, so up to the first period, so summarize what this function does. So you will see later it will go in the documentation file, and here at return it documents what it returns. And now let's take a look at another one, like set GPA at parameter. You need to document what the parameter is for. Alright, I comment out two methods. We will come back to those two methods later. It's a toString method and the equals method. So how about let's go ahead and compile this class. There's no syntax error, and now let's take a look at this one. So there's one nice feature about BlueJ is after you create a class, you can test it right away without writing any code. Of course, we should know how to write code to test it. We will look at this in the next part of the video. But now let's take advantage of BlueJ's this nice feature. So after we program a class, after you compile it, if you right click on this one, you see it allows you to create an object of this class. So first I create an object using the default constructor. I accept that name. You see that object shows up on the object bench. So I have this object. How about let's right click on this object. You see you can invoke the instance method. Remember, it's called the instance method because you need to invoke it on the instance of the class. So we say get GPA, it's 0.0, and how about get ID? That's the no. So how about let's create another student using the second constructor. So it asks for ID and it's a string, so I give it G10 double quote and I give it 4.0. Why not? Okay, let's see. Alright, I have student2 object, and now let's see, get GPA, that's 4.0, and get ID, and that's what I got. And how about let's say set GPA, let's give it 3.9, say okay. And how about get GPA, it's 3.9 now. So now we have two student objects here. And how about let's take a detailed look at this one. So we can create student objects. So after we create the student objects, we can test the instance methods on the student objects. And now let's see, there's another one. Get number of students. Remember, this is a static method, or called a class method. So for a static method, you can invoke it through the class. You don't have to invoke a static method through individual instance, because pretty much they don't have anything to do with the instance. They have something to do with the whole class. So when you invoke them, you can do this. Say, get number of students created. So far it's 2. So how about, let's see. Let's create another student object. So let's say G20 and 3.5. Okay, and now let's see, get number of students. It's got updated. It's 3. All right. So that shows you the difference between static method and instance method. For instance method, you have to create an instance first. So then you invoke those instance method. But for static method, you don't have to do that. You can, let's see, you can just right click on the class name and invoke it. It's the same when you write your code, you will see. Alright, so now let's take a look at more here. We have the instance method, and you see this one, it says inspect. If you click on this one, it's pretty neat. It shows you the current state of the object, and if you want to show static fields, it will show you the static fields. Alright, and if you get tired of this object, you can go ahead and remove it. And another thing I want you guys to take a look, you see this another one, it's called inherited from object. What does that one mean? So in Java, we have a unified view about the inheritance. It's called everything is an object in Java. So except for the primitive data type, but you can easily convert them into objects as well. We will talk about the inheritance in about 2 weeks, but right now I just want to give you a head start. It's just say everything is an object. That means we are all child class of a class called object. So we inherit a bunch of methods from this object class. You see we have a bunch of methods. Inherit means you get it for free. So let's take a look. So how about I'm going to click on this method. We got it for free from our parents called object class. So string to string. Let's see, toString method gave you back a string representation of the current object. So let's take a look at what did our parents do for us. This is what it did for us. It says student, the class name, at some memory address. Not very helpful. So it just shows student 3 as this. How about let's take a look at this guy. So inherit and toString. So that's still student at a different memory address. So I think it's reasonable. For the object class, this is a method you inherit from the parent called object class. The parent class knows nothing about us. We just create the student class. So the parent doesn't know you at all. So the best it can do is to say, hey, you're a student object, and this is the memory address you're at. Alright, so that leads us to something. We inherit something. If we don't like it, we can change it. We can override it. So let's take a look at the student class. So I purposely commented out here. So how about let's put it in. I provide my own version of toString. This is called overriding the one you inherited. overriding, when you do overriding, be very careful. You have to make the prototype exactly the same as the inherited method. Otherwise you're not overriding anything, you're creating something new. So I'm overriding, I say, hey, this is my internal state. This is the string representation of my internal state. So after I do this, let's compile this. And let's rearrange this. That looks ugly. Okay, this one's done. And now let's see. If I create a new student here, and I create another student here with and I create another student. Alright, now let's take a look. So now if you see my toString shows up here because I override the inherited one. This time it showed me no 0.0, better than the student at memory address. So now let's take a look at this one. You see it shows G10 \T because this box doesn't understand \T. Usually should be a tab there. So it's much better. Use override method. And another one I want you to look at is something called equals. Equals is something we inherit from object class as well, but we don't like it because for equals method, so how about here, student 1 and student 3, we create both of them using the default constructor. So take a look. If I do an inspect, this is what's in student 3, and if I click on inspect, this is what's in student 1. And if I click on this equals method, say is student 3 equal to student 1? It should be. I use the same constructor, but it says false. Alright, so think about this. This equals method you inherit from object class. The only way it can compare them is to compare the address. So the address should be different, but the attributes, they're the same. So if you don't like this comparing by identity, by address, you should override that method equals. So this is how I override the equals method. So keep the prototype exactly the same. So first of all, I'm going to test the passed-in object. Are you an instance of student? So first I'm testing, are you a student object at all? Maybe you're passing me a faculty or staff or something, then not equal at all. So this instance of is a new operator. So it takes a object and takes a class name and test if this object is an instance of student. So if you're not an instance of student, I'm going to return false. If you're instance of student, I'm going to compare the ID. How do I compare ID? I'm going to compare my ID to your ID. And you see here I did a typecasting. This object I cast it to student type, then comparing the ID. I will talk about this method more when we talk about the inheritance, but right now just try to read it. So now my logic to compare two students for equality is to compare ID. If they got the same ID, I consider them to be the same. Alright, so come back here. So I'm going to compile this one. Come back here. I'm going to create a new student and create another new student, and I'm going to go ahead and invoke equals. Oh, sorry, here we got a no pointer exception. So remember the ID, when I use the default constructor, they contain no object. They contain no, so you cannot compare to no apparently. So how about let's create a new student 3 with G10 and with 3.5. Okay, and let's create a new student with G10 again. So they got the same ID, and I give it a different GPA, but our logic for comparing to student object for equality is just comparing ID. So let's go ahead and compare this student to student 3. Okay. You see, it says it's true because that's how we implement the equals method. Alright, so that's our student class. In this student class, we explore the instance variable and the class variable, and we talk about the constructor, and we talk about overriding the inherited method, and what is toString for and what is equals for. Okay, in the next video, we're going to look at the test student class, which is going to use student object, how to create a student object, how to use it. Thank you.